The idea of inequalities today is things that aren't equal. We start off with this idea of equals, and equal means they're balanced, right? Like if x equals to 3, the only answer we can use is x is 3. And number line, 1, 2, 3. X has to be 3. That's it. There's no other choice. Now, there are pros about that because it gives us one direct answer, and we're good. If x is 3, if I say 5 x plus 2 is equal to 17, and x is 3, that means 5 times 3 plus 2 is 17, and that's true. This is a true statement. But in actuality, the world that we live in is not made up of equal signs. It's not. It's actually made up of inequalities. The example is whenever you guys go to a theme park like Disneyland or Magic Mountain, don't you see this little poster hanging out? It shows some kid and some little height guide. And they say that if you are shorter than this height, you're not allowed to ride. And they'll say if you're under 48 inches, right? Under 48 inches, that means you're not allowed to ride. That means in this case, your height, if it's less than 48 inches, you cannot ride. This is a no-go. The movie theater says this. How much does it cost for a movie ticket? Let's say it's $10. And if you have less than $10, you can't afford the movie ticket. If you have more than $10, you can afford the movie ticket. Your parents will say stuff like, hey, be back home before 10, right? Here's your clock. And 10 o'clock is like, oops, the short hand and the long hand, right? 10 o'clock. Be back before 10. That's something your parents will say to you. But do they get mad at you if you show up like at 9? No, because that's before 10. Be back, time is less than 10. If you show up after 10, if your time was, let's say, 10:30, then you're screwed because you came back afterwards. Now, today, what we're going to look at is why are inequalities important and how do we simply just draw them and write them? Two things, draw them and write them. Now, the first thing is, why are they important? Like I mentioned before in our day-to-day examples, is that that's how the world works. Inequalities are pretty much how we state everything when it comes to numbers. We never say, I have exactly this. You must be exactly this. It's always a range. Like, eventually you guys are going to start dating and you'll say, oh, I only want to date people taller than me, or I only want to date people shorter than me. I only want to date people that make this much a year. I only want to date, let's move on to a dating. Maybe it's a job and you say, I want to get a job that makes this much money or more. Okay, you never just want to say, oh, I want to make $10 an hour and that's it. I'm not going to look for any other jobs in the world, only $10 an hour. Well, I guess now it's like $15 an hour. But you'll say, I want to make more than $15 an hour. I guess some of you guys might say, I wish I could make less. But the world of inequalities is pretty much how we run things. Even when you're planning a trip, you'll say, okay, I can only spend up to $100. That's an inequality. I can't spend more than $100. So let's look at some words. And here's our idea. We have a couple of symbols that we're going to work with real quick. And these are little kind of like, not arrows in a sense, but they are, what they are these. They are equal signs that have been bent, whether you bend them one way or you bend them the other way. Okay? The equal signs that aren't equal anymore. So we've started equal and then we bent them. See, either they're going to weigh one way or they're going to weigh another. So here's what we're going to say. This is what we call less than. Why? Because A is less than B. Okay, this is a way you could write this. You could write A is less than B, or you could just write this. Now for you guys, which one do you think is easier for you guys to write? One with the whole sentence with a lot of words, or just 3 symbols? I think math is pretty eloquent in this way, where we can describe ideas. It's just simple symbols. So A is less than B. Now let me give you a couple examples of this. Is 3 less than 5? Yeah, that's true. Is 2 less than 5? Yes, that's true. But is 6 less than 5? Not true. Okay, so this is not a true statement. And we read from left to right. We're in America here, we read from left to right. So we always start from this way, and we read this way. If you want to read backwards, you can. But we have to say this, that B, let me write this in a different color here. B is bigger. See how this is on the bigger side? B is greater than A. If you want to write this way, if you have to say B is greater than A. So you could read it backwards, but you have to make sure you change that word, because as we change directions, we have to switch that word from greater than to less than. So in English, you could say this as example, I am older than my sister. But if you switch it around, my sister is younger than me. So it always depends about which direction you're going. Let me draw you a simple picture of that. Let's say I am 9 years old and my sister is 6 years old, okay? I am older than my sister, going this way. So you would use the word older, right? But going the other way, my sister is younger than me. So even in English, we switch around words depending on which order, which way you read it. The same thing for these inequalities. If I go one way, and if I go back the other way, the words change, but they are interchangeable. So let's look at the next one. This would be a greater than symbol. Now, one way to look at this is that A is greater than B. A is greater than B. Okay, is that, I mean, in elementary school, you have seen this one where they draw little crocodiles, right? Draw teeth. Right, a crocodile or alligator. But we don't need that. We can just see that math is very eloquent to say this is the larger side. A is bigger than little tiny b. A is bigger than little tiny b. If you want to go backwards, we can say B is smaller. Look, B is smaller than big A. So B is less than A, if you want to read it backwards. But in general, we read it from left to right. That's how we read these statements. Let's continue. This one looks like this guy here. They look like each other. They're facing the same way, aren't they? Right, these two are facing the same way. So we would still say less than, but we have a little symbol on the bottom. This is going to be less than or equals, less than or equals. Okay, less than or equals. Because, so A, let's write A and B. A is less than or equals. Because you don't always have to be less than. Sometimes you can be equal. So this gives us an additional circumstance where we can say not only do we have to be less than, but we could also be equal. And the last one here is greater than or equal. And again, when you write a little line on the bottom, you allow it to also be equal. From left to right, A is greater than, look, it's so much bigger than little b. A is so much bigger, even a little bit, as long as it's greater than B. Then A is greater than or equal to B. So there's a 2B back here also. Okay, the first goal is to make sure we can read each of these symbols very quickly in a very easy way, deciding is that an equal or not equal symbol. And the next thing we're going to look at is graphing. So, but let's go ahead and look at this one more time. This time in a graphing approach, graphing way. If I write x is greater than 2. So think of some numbers that would be greater than 2. Well, if x was 3, that would be greater than 2. If x was 4, that would be greater than 2. But what numbers wouldn't be greater than 2? If x was 0, that would not be greater than 2. How about if x was 1? 1 is not greater than 2. Now I want to show you guys that. If I put 1, let's write over here. If I write 1 is greater than 2, does this look like a true statement? Does 1 look like it's on the bigger side? Does that look greater than 2? No. So what happens is math people came up with a really efficient way to say, is it greater or less than using the symbol? And instead of writing out the word greater than or less than. But that's what's running in our brains. We're thinking that's a greater symbol. So we know this is not true. This is not true. Okay, so how do we draw this? So we're going to draw a one-dimensional number line because we can go in one direction. Draw a 0 here. We're going to write numbers 1, 2, -1, -2. So on this problem, what we're going to do is we're going to identify what our equation is saying. In this case, our inequality, and that's saying 2. And we're going to draw a hollow circle. Please notice this is a hollow circle. And the reason why it's a hollow circle is because we are not equal to 2. We are not equal to 2. You are not allowed to stand on this line. If you guys ever play basketball, if you have the ball and you step on the line, are you in or out? In basketball, if you have the ball and you step on the circle, you are out. But the rules aren't for every sport the same way. If you're in soccer, if you guys play soccer, if you have the ball and you're dribbling the ball and you step on the line, are you out? No, you're perfectly fine. So let's look at this. This graph says that x is greater than 2. That means we're going to draw an arrow to the right. Because numbers that make this a true statement are 3, 4, 5, 6, 7, 8, 9, 10. All the numbers on the right side. And would you agree that this whole right side section is larger? This is all larger, greater than 2. It's all greater than 2. Let's try another one. If x is greater than, let's do -1. So what you would do, draw a simple number line. And that could be as simple as this. This could be as much as you write. Am I allowed to be at -1? No, this is not an equal one. This is just greater than. So I draw a hollow symbol because we're not allowed to touch -1. And we have to be greater than it. So we can draw an arrow to the right. Now, what numbers are greater than -1? Imagine if you owe me -1. If you had $1, $2, $3, $4, $5, you'd be greater than -1. All these are possibilities. 6, 10, 100, 1000. These are all numbers that are greater. If I write x is less than, okay, let's do an equal one, okay? Here's the equal version. Less than or equal to 3. Let's draw a number line. And this is all you have to write. 0 and 3. That's it. You could add more detail if you want, but if these are your notes, no. Now, here's something I want to say. Is 3 less than or equal to 3? Is 3 less than or equal to 3? Yes, this is a true statement. That means we're going to draw this in a different way. So please take a look. Instead of drawing a hollow circle, we are going to draw a solid circle. Look, this circle is totally filled in. We're going to go to the left. Okay. That's how we draw the difference between equals and ones without the equal sign. Let's do this one more time. If I say x is greater than or equal to, let's say -2 this time. I'm going to draw a simple number line with 0. Here is -2. Now, do I draw a hollow or a solid point at -2? Hollow or solid point? Because this has an equal sign, that means we are allowed to be at -2. Go ahead, you can stand on the line. And when we're greater, numbers that are bigger, remember this idea is bigger. Bigger is going to be on the right side here. Numbers on the right are bigger than numbers on the left. The last simple task that we're going to look at today is going backwards. If I draw you a number line, here's writing the inequality. I'm going to write the inequality here. Draw a simple graph. Now if it's the same number, let's say it's going to be number 2. I'm going to draw the graph that looks like this. It's going to be hollow, going to the left. This is going to be solid, going to the left. Okay, these graphs almost look exactly the same, but please note, this is hollow, and this is solid. Now both of these graphs indicate almost pretty much the same thing. 0 is less than 2. That's true. -1 is less than 2. These all work. These all fall within the boundary of this graph. If your mom said, you can only play less than 2. Yeah, we're playing over here. We're less than 2. We're all less than 2. Imagine if your mom said, don't play on the street. Then you're not allowed to touch the street. Some of your parents say, yeah, go ahead, play on the street, no problem. So this is how we write them that are different. That's right, x and 2, x and 2. Now for my left one, since it's hollow, I am not allowed to be on 2. So we're going to use the symbol less than, because we're not allowed to be on 2. On the problem on the right, we are still less than, but because it's solid, we can draw a little line underneath and say we can be less than or equal to 2. And that's really the only difference. And you just have to make sure you catch those small details. Okay, again, on the left side, we are less than -2. And on the right side, we are less than or equal to. Okay. So for your IXL task today, you're going to work on graphs of this. X is greater than 3. So first thing you're going to do, you're going to tap on 3. And since we're greater than or equal, you get a choice. And as you can see, as I tap it, it can be hollow or solid. And if it's solid, well, we're allowed to be on it because it's equal to 3. And then as x is greater, we're going to go ahead and tap on the right side. Whoops, we're going to tap all the way to the arrow. I'm going to tap all the way to the arrow. Submit. I'm done. Let's try this again. The number is 6. Tap on it. But if you look at it, this is x is greater than 6, not equal to 6. So we are greater than, not equal to. So that's going to be hollow. And we're going to go all the way to the arrow. This is how fast it's going to be. Then one more. X is less than 2. Here's 2. We are less than or equal to. So because it's an equal sign, we can be solid. And we're going to left. Okay. You guys have 2 Excel assignments to work on today.